Okay, so let me introduce you, Dr. Rosemary Hipkins. Rosemary Hipkins is a chief researcher at the New Zealand Council for Education Research. She began her career as a secondary science and biology teacher and worked in teacher education before moving to NCCER. Rosemary was actively involved in the development of New Zealand's current national curriculum framework and has led national research projects related to both curriculum and assessment innovation in New Zealand. She is interested in deepening understandings of OECD's key competencies and how schools co-led the development of resources to support their meaningful implementation across the curriculum. She is going to talk about systems thinking for democratic participation.
Just grab that. Ooh, that was disconcerting. Oh, hello, everybody. Thank you for coming. Thank you for having the stamina. I don't know about you, but those of us from the other side of the world, I think the delayed jet lag's probably kicking in a wee bit, and the pace is quite tiring. Can I just say, by way of a disclaimer before I start, I don't regard myself as an expert on systems thinking by any means. I never would make that claim. But I think it's one of those things that's so important that we've got to find a way to start somewhere to do it. And I've been having a little play with some of our teachers at home. And so I know that the things that I'm going to do just open up some questions about how we do things differently so that we try to help our young people think in terms of systems. So I'm going to start by saying a wee bit about why it's important. And just so I don't repeat myself and sound too boring, can I see, first of all, who came to my talk this morning? Oh, just a few people. That's good, actually, because that's the place where I want to start. So that tells me, forgive me, the people who were there this morning, I'll just tell the people who weren't a wee bit about the story of this book at the top. And this is where I take the idea of democratic participation from. So we've got a version of the OECD's key competencies in our curriculum in New Zealand. And with three of my colleagues, whose names you can see up there, Rachel Bolstad, Sally Boyd and Sue McDowell, I recently did a project in which the question we asked ourselves was, if we want our young people in their futures to be the sort of people who can build the future we want, rather than just coping with the future that comes at them, what sort of ways do we need to take the key competencies forward in the curriculum so that we'll be able to do that? Now, this morning I talked about the process that we use to do it, and if you want to ask me about that afterwards, feel free. I did explain it this morning. It's not that I don't want to again, but I promised this to be a workshop, and you've done an awful lot of listening. I want to have some doing. Although I must say it's going to be a wee bit challenging in the space. But we'll see what we can do. I wonder how good you are at sitting on the floor or maybe on the edge of the stage. We'll see as we go. So systems thinking came up as one of the capabilities that it's really, really important to develop in our young people. Because wherever you look at the problems that beset the world, they're systems problems. They have hidden connections. There are bits to them that we have to dig really hard to find. When we try and fix that one bit, something else happens. And we teach a lot of the way that we teach doesn't accommodate that complexity easily. We definitely have to do some things differently to do that. And if we don't, we're not getting our kids ready to be good citizens in such an interconnected world. Systems are really, really important. And I said, who's read David Weinberger's book, Too Big to Know? Anyone read that? It's got a great long subtitle, which ends up with, and this is after 20 or so other words, and why your computer might be the smartest person in the room. Does that ring any bells? In his book, he talks about an IT world, a tightly networked IT world, being an intertwingly world. And obviously that's a word he made up, but I think it's a really expressive word. So if our kids are going to live in this intertwingly world where things are connected in all sorts of ways that we know and we don't know, then obviously we need to teach them to think about that. So I'm not the only person who's come to this conclusion, or should I say we, because it was a team of us who worked on this book. How many of you have read The Triple Focus? Only one person in the room. Have you seen, were you aware of The Triple Focus? If you look at the names of the authors, you can probably guess what they say those three things are. And because one of the authors is Daniel Goleman, who I'm sure everybody will have heard of. He's the emotional intelligence guy, right? So he's, two of the planks are the social emotional ones, the cell skills, as some people call them, which I think is an awful term, but anyway, the whole cluster around self-management, which we've been hearing about again and again, the cluster around relating to other people, working in a team, things like that. But the third one, and this is what interests me, because if you recognise the name of the other author, Peter Senge, you'll know that he's a guru of systems thinking in the business world. And so these two have somehow found each other and teamed up. And they're advocating that our young people in their futures need those two sets of competencies, which are well covered by the key competencies, and systems thinking, to be citizens in the 21st century. It's an interesting little book. It's what I call a read in a weekend book. Somebody else described it recently as an extended essay. So it's not long, but there's a frustration at the heart of it for me, which is most of the examples and descriptions that they give are extracurricular. So the question for me always is, what does this mean inside the curriculum? What does it mean about how we change the teaching and learning? Now, obviously, in an hour, we can't answer that question across the curriculum at all levels. What I want to do is just for us to have a wee experience of one way that might work out that we teach something that's very commonly taught differently, so that you can go away and think about what that might mean for other subjects that you teach in other areas. And I just put a few images up in here to remind me to say that this isn't only important in education and only important for young people while they're at school. If you read the URL along the bottom there, you'll see, I don't know this company personally, I suspect it's a European or an American company, Buddha Jeans. Anyway, it's a fashion company. And this is a systems model that's been developed by somebody looking at the impact of their fashion manufacturing business. And so when you see these sort of images on the internet, this tells me that it's actually going to be not just for citizenship, but part of the working life of a number of our young people. And that just reminds us that systems can be quite complex, but I'm not wanting to go through that. So the focus for us today is, can our kids be systems thinkers? Is this asking something that we oughtn't to be asking of them, or can they do it? Can they be integrated into the curriculum? When can they start? Is it too hard when they're little? Do they have to get to a certain age before they can do it? Now, it turns out that there's a bit of research that addresses this. I've got a summary of some of it, just in note form, because I didn't want to carry too much in the way of handouts with me from New Zealand, but I've only got 20 copies. So if you're here with colleagues, can I suggest that you just take one of them? And if you don't get one and you want one, feel free to email me and I will send it to you electronically. So I've said, see the handout, it's just a two-sider. It's got some of the research there, just in bullet-pointed form. Although actually, since I did that, I've developed it into a short journal article, which will probably be online soon because it's going to be published in the New Zealand Science Teacher. I was a science teacher when I was a teacher, as I said in the introduction. So one of the groups that's been doing a lot of thinking about systems thinking is the Waters Foundation in America. And they have some very clear recommendations to make about the sorts of learning activities that can help young people build their systems thinking capacity. They're big on role play and simulations, and also on using visual resources. And while they're just little symbols there, each of those symbols stands for a specific resource that they use. For instance, the one that looks like a stylized triangle at the top is actually just a little symbolic image for an iceberg. And, you know, I've been using an iceberg metaphor to get teachers to think about key competencies in the New Zealand curriculum for the longest time, and I never even knew that systems thinkers thought it was a systems thinking tool, and this one's a ladder of inferences, and they've got names, but this is just to show you that there are quite a few strategies out there, but that doesn't address the question of how you pull them into the curriculum and what you do with the content of the curriculum, which is my main focus. There's the iceberg one. It's obvious, it's used as a visual way of getting people to think about the parts of the system that are hidden. So you can see that this one there it's off a website called Well People, and it's designed to show the things that contribute to your health, the things that are everybody knows, obviously, and then the deeper layers. That's quite clear, isn't it? Have a look at this one. This is way, way too busy. And I'm not going to unpack all of it. This is another one off the Waters Foundation website. Really, I just want to concentrate on the words through the middle. You can't even read the rest of it. I can't read the rest of it. But what they've got is the things that's visible, the bit of the iceberg that's above the water. Interesting that this metaphor's already popped up in this conference. And now, in the blur of all the talks, was it David Perkins who used it? Was it Howard Gardner? I think it was David. Yeah, yesterday. Anyway, that's the event. Then just under the surface, where with a bit of digging you can figure them out quite easily, are patterns in behaviour, whether it's behaviour in a system or of people. Then the structures that actually drive those behaviours, a bit deeper, because they can be quite hidden from view. And then finally, deepest of all, where we have to work hardest to get at them, our mental models and assumptions of how the world operates and how things go together. I could say a lot more about that, but I'm not going to today, or I'll get too distracted from what I want to achieve in the workshop. But that model there opens up all sorts of possibilities for organising information, I think. One of the things that I found interesting when I reviewed the literature, and Jane, I found this extremely interesting after our conversation and our working session yesterday, is that one of the things that's important to pay attention to is the embedded cycles that are inside systems. So it's kind of like unpacking the layers of them. And it's actually embedded cycles and systems that I want us to explore today. The reason I'm chuckling about this one is because we had a conversation yesterday about waste minimization cycles not really actually being organized in a systems way at all, because they're very linear, and you can see that so clearly. Needless to say, I'd put this PowerPoint together before yesterday, or I might have chosen something different. But just to show that inside systems there are cycles, and that one's too simple and too linear. And so just to correct my mistake, and I did have this here before, what I've got now, and what the first time I'm going to stop and ask you to talk about this is just a picture. This is a New Zealand scene, and if you read carefully along the URL at the bottom, you can see that the agenda of the person who posted this picture was environmental, because part of that tag is dirty dairying. In other words, the impact of dairy farming on the environment. And it's probably fairly obvious how that operates. But what I want you to do, just have a conversation about that little farming system that's captured there in that simple picture, and say, how many cycles can you see identified in that one little system? Talk about that now with people sitting close to you, and then we'll hear some ideas and we'll move on. I'll give you about 4 minutes. Is the question clear for the people who speak Spanish? Not clear? Well, I'll give you one to start with. Obviously, the water cycle is implicated here. Yeah. That's enough to get going? Good. The question makes sense? Yeah? Hello. Hola. Everyone's being very quiet and tentative. Hopefully, in a minute, I'll be able to get some more energy going. Somebody want to share one with me? So I've already told you the water cycle, at least, is implicated there. The cycle of the seasons. That I hadn't thought of that one. Fantastic. Yeah, the carbon cycle, the nitrogen cycle, life cycles of the organisms. Any others? What about the cycling of the gases in the air? You got that one? Yeah. Sorry, I anticipate what you're going to say. You get the point anyway. Inside a system, there are many cycles, and they intersect with each other and interact with each other. And you can see here in this diagram that someone's made an attempt to show how, when you understand how these cycles interact and impact on each other, you can do some things that actually lessen some of the negative effects of some of the cycles that are implicated in things like making our food. In this case, something as simple as planting trees along the edge of a waterway. So, what I want to do then is stick with this idea of the water cycle for a minute and say, can we teach the water cycle in a way that brings its systems potential to the fore, rather than just being a simple water cycle? But we need to start with a simple water cycle before we can address the question. So what I want you to do, and you can do this in pairs, and it's not a test obviously, is draw a water cycle like you learnt it at school. Draw me a water cycle, just so we've got what our beginning point is in front of us. Grab a piece of paper, do it in your notebook, wherever. If I was doing this with kids, I'd give them big paper and pens. Sketch a water cycle. Understand? Yeah? Can you remember? Think about what it looked like in your school textbook. In a minute, we're going to talk about what's wrong with this image, how it's misleading. Everyone got something sketched down? Yep. Shall we move on? Okay. Does yours look a bit like this? Obviously, it won't look exactly like that. Yeah. Now, what I want you to do is look at that image, or your image if you prefer your version, which would be fantastic, and see if you can work out and say, you can tell each other, if you're brave enough, you can share it with me, 2 or 3 completely misleading ideas about how water behaves in the world or how the water cycle is in the world that you could come away from your learning with if that was all you learnt and that stood for the complexity of the water cycle. What's misleading? Not intentionally so, obviously. Have a conversation about that. Do I need to give you one to get you started? Or do you understand the question? Understand? Quite interesting to put our familiar school tools to critical scrutiny. Someone like to share? Yes, go for it.
We've come up with 2. The first one, that the cycle is constant and consistent.
That it just keeps going continuously, yeah.
When we can have droughts and floods.
Yes.
The second one we came up with is that humans aren't interfering in that cycle.
Right, humans are an absent presence. When we draw these systems, we leave us out. And that's a very good point, and I'm so glad you made it. I'm going to come back to it a bit later on. Others? Other ideas?
Yo también pensaba que
I always thought that this is not always the same throughout the world or in all places.
English to translate.
Not always the same.
Sorry?
It's not always the same in some places of the world.
Yes, I get it. So, here in the Basque country, that probably looks reasonably familiar. Certainly in New Zealand it looks reasonably familiar. But you could say to yourself, does this mean you have to be in a country that has mountains before you have a water cycle? Is there such a thing as a water cycle in a desert country? Or doesn't it exist there? That's a good one. Yeah. Others? Sorry? Ice is a missing presence. Yes, it's not there. What Jane said was that the influence of ice is not visible. Sorry? Oh, we'd be, or if I need it, yeah. Others? Sorry? Uh-huh.
Madam, can you hear me, madam? This is the interpreter. Can you hear me, madam? Can you hear me, madam?
Now you... Oh, that's on the wrong channel.
Madam, 1 2 1 2 1 2 1 2 1 2. Can you hear me now, madam? Good.
Others? No? Anyway, you get the point. One of them, it looks as if it only rains in the mountains. Does it rain over the sea? Yeah, there are others that we could have. But what we're going to do now is I'm going to give you a different water cycle. And this is where it's going to get interesting. Because the room isn't very well configured for what I'm going to ask you to do with it. That's what it looks like. I've got maybe 20 of them here, and I want people to organise themselves into groups so that you can see one of these and interact with at least 2 or 3 other people. So if you want to come and sit in a space where there's more room, that's fine. If you want to sit on the floor, that's fine, or on the stage, that's fine. I haven't actually counted them. They tend to walk. And I'll say at this point, I've got no intention of taking them home to New Zealand. So if you want one, make sure you get one. Okay, here they are. Organise yourself into groups and come and get one. They're quite heavy. It's a bit awkward to do with the translation thing in my hand.
I know, madam, but it's useful. Madam, you don't need to keep them on as long as there's no interaction. If nobody's speaking in Spanish, you don't need to.
One more. Okay. Everyone found a place to settle?
Can you tell the people when they are going to speak like long, that maybe
Yeah.
I can give them the microphone, I can leave them, but just because I'm running around and I don't catch up.
Yeah.
The traductor man say that it's better that you put your translator.
When I need them, yeah. Now you've had a chance to have a wee look at it, I want to tell you a couple of things, and then I'll tell you what I want you to do, okay? So most people are settled in a spot now where they can look at one. When I give this resource to teachers in New Zealand, and I've done this on a number of occasions just recently, a typical reaction that I have from them is to say, our kids can't learn that. It's far too busy. It's too complicated. And just listen to the words. Our kids can't learn that. Now, this is not designed to be learned. This is designed to be explored and experienced. So what I want you to do, I've put the little words in the circles. I've had them translated into Spanish if you need that to help you. I want you to figure out how this thing works. What is the difference between the colours on the tracks? What's going on here in this version of the water cycle? And I want you to see if you can come up with 2 or 3 questions about what's going on that you could ask someone else. That clear? Have an explore. Figure out what's going on in an actual water cycle. I might need the headphones. Yeah.
Hello, madam. Are you tuned in? Can you hear me? Okay, good. Okay. Now we just need to make sure that they use a microphone whenever they talk to you in Spanish.
Can I take that?
Okay.
Yeah.
I'm gonna. Yeah, it's now.
By the way, I'm the interpreter, and my name is Carlos. If you need anything, you just... I'm up here. I'm up here.
There's all sorts of cycles inside the cycle. Yeah.
And there are some that they are like both sides, no? That they feed each other's.
Yes.
They have both.
Yes.
But it's only one, it goes only one direction,
Yes.
right?
Yes.
Okay.
You got it. That bit. Okay. I've got one eye on the galloping clock. Always the clock is our enemy when we get interesting things to do. Who would have thought the water cycle could be so interesting? Would somebody like to share a question or a discovery that they've made?
And how salt water can be transformed to humans and animals to be consumed?
Yeah, there's a line there that shows salt water going into animals. How is this possible? Is this possible? Is there a biologist in the room who can answer that question? I'm bringing the microphone to you.
Okay. Well, I don't know. Yes, I think so. There are many animals living around salt, and in a way, they get that salty water. So I guess it is in the, not maybe in the organism itself, but maybe it's in the structure. It can be like in different bags inside of these animals, and then we can get them. So it's like they can enter in animals, I think.
Yeah. Oh, well, for animals that live in the air, that's a possibility. What about fish that live in salt water? Where do they get their water from? It just, I mean, in the bigger scheme of the water cycle, it doesn't matter in a way, but it's an interesting question because it's a sort of question that's never raised by the flat and static diagram. Another one? Somebody else want to share something they found? That was great, thank you. I thought you were going to ask a different question about salt water, actually.
One question might be the impact of a major change in one of those waters sources on the others, such as the melting of the ice caps.
Yes, if we get more fresh water and less frozen water, what will the effect of that be on the overall cycle, given that this is so complex? Good question. And not a question we can answer, although we could make some predictions. Another one?
One really simple question we asked looking at the diagram was why in the top right-hand corner with rain, hailstones and snowflakes is that only blue and everything else has got green or blue in terms. So that made us think about the direction of the arrows and what the difference was between blue and green.
Right. Did you all hear that? Yeah, so what's that corner up there is a wee bit different, isn't it? Because everywhere else is a place where water is, and that's a circle of processes. Did you notice that? And they're all driving in a single direction, whereas the others are more, they've got more complex interchanges. What is the difference between the green and the blue? Did you figure that out? Did you ask yourself that question?
It's two directions in the green and one single direction in the blue ones.
So, if you look at the ones that go in two directions, then you have to say, potentially, if water, for instance, was going from fresh water to water vapour back again, that's a cycle, potentially, that's a cycle inside the cycle. So the water cycle isn't one cycle at all. There's a potential for there to be many cycles there. Okay, one more.
Aquí nos hemos dado cuenta.
Here we realize that depending, well, the colors have a different number of cards numbers. Here we've got 8, here there are 6, here there's...
And you're asking me if that's significant. That's just what the designer did, but people do notice that and ask the question. And we are actually about to redesign it so that there aren't distracting things like that there. There are some things about it that are not good design. This is one of the reasons I don't want to take them back to New Zealand, because we're actually about to completely redo them. But thank you for noticing that. Okay. Does anybody want to make a general comment about how they think their students, and tell me what age they are, would experience an activity as simple as that with something nicely produced like this? Would they like it? Would it intrigue them? Would they find it, as some teachers in New Zealand fear, too busy? Does anybody want to make a comment on that?
Well, I've worked with this, the water cycle with 8-year-old kids or 9, and we didn't go into much depth, and I'm sure that they would have been much more interested had they had this one.
In fact, we have used this resource in New Zealand with children as young as 7. And one of my colleagues had the experience of these young children not wanting to go outside at lunchtime because they were so busy having fun. The teacher had invented a game with some rules and was using it for that purpose. And it's been used by university students in a geography class. So it's got the potential to be adapted to lots of levels. But my purpose in telling you that is not to sell the resource. I've just told you we're about to redesign it, and I'm giving this version away today. But just to make the point that when you do actually stop and think about the complexity that's under something that we present so simply, it immediately becomes much more intriguing for children. I can think of an exception. I can think of a secondary teacher who said to me, "Oh, well, yeah, okay. My kids got it straight away, and then they just wanted to move on to the next thing." Now, if you think about a comment like that, it's kind of saying, don't touch me with this learning. Don't make me learn something that might mean I actually have to care about something. And we're back to dispositions, which has been the theme of so much of what we've talked about. So I think that this can be done, that we can, with some thought, convert even quite simple things into a systems way of looking at them. And one of the things that I like about this, and it didn't so much come up in the questions just now, was that it introduces the contexts where water is found. It doesn't just take them for granted. One of the things that we found we have done some research on systems thinking, and it's told us that it's important to take context seriously, not just concepts. Because in a system, both are important. That makes sense, doesn't it? Those of you who are sitting on the floor, do you want to come back to your seats so that you're more comfortable? And we've just got a few minutes to finish off. Yeah, you take that one. For now, yeah. Yeah. Okay, just to finish off this little part of the conversation before I don't think we're going to have time to do the last activity that I wanted to do. What time does this workshop finish? 4:30? Yeah? That's all right. We'll make it nicely to 4:30. I'll leave you with the last activity to take away with you. Somebody commented before that humans and the made world are typically missing. And so in terms of thinking about systems thinking, what message do we give our children when we introduce important systems in the world and leave us out of them and the things that we do? That one's quite interesting. An urban water cycle, just showing how it disrupts where water flows. The next one, and you won't be able to read the words of it, but you'll get the gist of it, is downright scary. Look at this one. This one shows how drugs that we've made and we use ourselves or feed to animals or whatever get into the water and then cycle round and go places where we're not even aware that they've gone. How scary is that? Now, is it important that this one probably is not one that you would be looking at with primary school children, but you could imagine that adolescent students could get pretty passionate about something like this and might be looking and asking some quite hard questions about how it applies in the area where they live. I find this one very scary. So the point here is that when we're thinking about how we develop a more complex and intertwingly view of systems, it's important that we put ourselves and our actions into the system too, not stand outside it as if we can somehow look in without being part of it. So all that is pretty scary in some ways. So one of the reactions that I've had to that resource when I've used it in New Zealand is, I think, as I said to you before, people sometimes say it's too busy. Another thing that some teachers say to me is, my kids can't learn that. They can't draw that in a test. Well, of course, it's not designed to be drawn in a test, and it's not designed to give you right answers, because when you're learning to be a systems thinker, what you need to be able to do is to realise that sometimes there are several possible answers, and what happens depends. So if you look at some of those circles, there's not one way in and out of them. So if you imagine yourself as a water particle and where are you going to go next? Well, it depends. You go one way, something will happen. You go a different way, something quite different will happen. So there's a different sort of thinking. We call it depends thinking. It applies in all sorts of areas, not, I've used the context of the water cycle today, but all across the curriculum, there are areas where students can be practicing it depends thinking, and it's absolutely critical in systems thinking. It can be very unfamiliar for children who are used to giving the right answer, and also, especially I might say, for those who are used to being the quick first person to get the right answer, some of the very brightest students. So, that's just summarising what I said. It's absolutely critical that we teach kids to do it depends thinking as part of what they're doing. It's underpinned by some key habits of mind, and those of you who were there this morning will know about this. The next thing that I'm going to show you looks far too busy and we're almost out of time. I've bought 30 copies of it with me. This is off the Waters Foundation website, and that's the top half of the diagram. There's a bottom half with a few more habits on it. I've got 30 copies of it here, but it's on the internet. Anybody can get it readily if you want it. What interests me is how the habits of being a systems thinker overlap with what David was yesterday calling brain hacks, or what Guy was looking at today about character learning. There's not an infinite set of habits of thinking that kids need to develop. Some of the same habits underpin systems thinking as underpin others. So what I was going to end with, and we don't have time to do it now, this is another systems tool, and this is such an easy one to use. So I'm just showing it to you, and you can, who knows this strategy? Does anybody use this strategy in their class? No? One of the things about systems is that they can behave in ways that we don't predict. And a change can happen, and all sorts of other changes happen from that change. So this little thinking tool is called a consequence wheel. And it's very, very simple to do. This one gives you categories, but you don't have to do that. All you do is put the change in the middle, and then you think about the things that will happen. And then you think about the things that will happen when those things happen. And so it goes. It's really simple and easy for children to learn to do. And it's one way of starting to develop some of these habits of systems thinking. So, in the very short time that we've had, what I've tried to do is to show you that there are some very simple strategies that you can use. There's lots of examples of them on the internet. These sorts of learning and thinking strategies are very, very easy to adapt to any context. It's a bit harder to make something like that water cycle resource, but it's not impossible. And if we don't start doing this, then our children aren't going to learn to be the resilient thinkers, aware of unintended as well as intended consequences, which actually I think is an absolutely fundamental thing they need to develop to be good citizens in an increasingly complex world in the future, part of what Guy would call their character development. So I don't know where that hour went, but if I've given you at least one or two little ideas to take away with you, then I'll be happy. I'll just put the handouts up the front here. I'm sorry I've got so few of them. I wasn't expecting so many people to come. I thought hundreds of choices. There'll be a few people, but anyway. Thank you very much.